So what happens when you're exposed to a lot of radiation? Acute radiation damage refers to being exposed to large amounts of radiation in a short time, as opposed to a more chronic exposure, small amounts over a long period of time. Situations in which you'd have acute radiation damage would be nuclear bombs or exposed nuclear reactor cores. So workers at nuclear power plants where there's been an accident, they can be subject to acute radiation damage. What happens here is that large numbers of cells die. Again, my pointer, what the heck? It likes that word, it only points to that word, fine. Large numbers of cells die, especially those in your immune system and in the lining of your intestines. So then your immune system's weakened, meaning you're at the mercy of any germ or virus that comes along. And with your intestinal lining damage, you're not going to be able to absorb nutrients. And so then you've got basically a starvation, even if you're eating. You can recover from mild cases of acute radiation sickness, but in more serious cases, the individual usually dies from infection because their body can't fight off the infections. Lower doses of radiation over long periods of time, a more chronic exposure, can increase cancer risks. Radiation can damage DNA. Often this will kill the affected cells with the damaged DNA, but it can also cause them to grow abnormally, reproducing out of control, and that's what we call cancer. Cancer is a type of tissue that's growing out of control. The cancer risk would increase with your increasing radiation exposure, but there's not really an exact threshold for where that increased risk begins. And it can't be determined because nobody wants to volunteer as a human subject, right? You can't do experiments on people, not with dangerous things like that. And so we don't know a lot about that because we can't experiment on humans, nor should we experiment on humans. Yes?
You talked about it before in chapter 9 with light waves, but you know there's a controversy that microwaves cause damage to the food, but would they not have enough energy?
So there are people who believe that your microwave oven is ultimately going to kill you or cause you serious harm because it's got radiation in it. But microwaves are much lower in energy than visible light, right? And I have not read all the controversy about this. I'm sure there's pages and pages on the internet. The reason that microwave radiation will heat your food is because it has a frequency that is absorbed by water molecules. And it causes the water molecules to vibrate faster and have more thermal energy, and the temperature goes up. It does not damage your body. Now, if you were to microwave something that was alive, it would kill them. But not because of radiation. It would kill them because of the extremely high temperatures. You basically would get cooked.
How about changing the nutrient content of the food?
I really don't see how microwaving food can change the nutrient content any more than cooking it, heating it to the same temperature in any other manner. Heating a food does cause changes in the nutritional content, right? But microwave or heating it on the stove, same effect.
Why does microwaving bread make it rubbery?
Why does microwaving bread make it rubbery? That's a good question.
Probably did it too long.
Well, yeah, you did it too long. But why? Why, when you do it too long?
You did it too long.
Because. So there's a lot of chemistry involved in food.
Are you serious?
I am serious. There's a lot of chemistry involved in food.
Screw it. I'm going to eat it because I need it. I'm going to want it. You know what I mean? mean,
Well,
like,
well, no, you need to eat
this
it.
carbon mixed in with this and that, like.
So some
correct.
people are interested in the chemistry of cooking, and other people aren't. So if you're not, fine, just enjoy the food. I like food personally. But when you bake bread, when you make bread, the kneading of it does things to the gluten proteins and causes it to have the texture it has. If you over knead it, if you under knead it, if you don't use enough yeast, all of these different things affect how the bread tastes and the texture of it. When you microwave the bread, the water content in the bread, it gets very, very hot, and you've probably noticed if you want to heat up like a dinner roll or something, it only takes a few seconds, right? Whereas if you're trying to heat up like a potato or something, it's going to take longer. And that's because there's not very much water in the bread. And water has a high specific heat capacity, so a low amount of water, it's going to get hot fast and then be done. You can boil away all the water and cause your bread to get really dry, but I suspect that the heat causes some changes in the proteins in the bread, and yeah, you got to be careful when you microwave bread, baked products in general. Yeah, because it can do a number on them. There's all sorts of weird things that can happen in a microwave, but is it toxic? No, not toxic. It's in this internet age, crazy people can stick all their crazy ideas out there and sometimes they make them sound pretty good. They can make them sound pretty good. You read that and you're like, oh, and you can get all upset about it. So you really have to read with a critical mind when you hear anything that people are talking about. One of my things is if the grammar and spelling are bad in the article, I am discounting it immediately because if you're not educated enough to spell your words correctly and use proper grammar, I am not going to believe your science. Sorry, not going to.
That's not fair.
Why not?
I'm not a native speaker. Right.
Well, so if you have serious knowledge of something, and maybe you're a bad writer, a bad speller, that doesn't mean you're a bad scientist, but if you're an ethical, believable person, you're going to get somebody to proofread it for you.
But that is too much. I'm
Yep.
trying to get it to the people.
Yeah, but should we believe anything that you say?
I feel like I'm credible. I just can't spell. I mean, I'm not going to write no article on chemistry. I'll tell you where to get your hair from.
Well, that's fine. I'd probably believe you on that one.
I mean, I spell it right, but you'll get the
Yeah, but in terms of a scientific article claiming, showing data and stuff, man, if you don't spell the words right, it's like, you drive down the street and they're selling nectarines at the fruit stand, right? But they spell it Nictrines. Nectarines. Nectarines. I am not buying nectarines from people who can't spell nectarine. Just saying. Okay, genetic defects, which may lead to people not being able to spell. I don't know. Trying to pull it back in here. Radiation exposure can cause genetic defects. We have observed, so the pointer's still off. We have observed genetic defects in laboratory animals, but they have not been verified in humans. Even studying survivors from Hiroshima, there's not really any reliable research suggesting that defects are caused by radiation. But it's reasonable. We've seen it in animals, and it's reasonable to suspect that it could happen in humans. So, humans reproduce by the combination of an egg and a sperm. If the DNA in one or both of those is damaged, then the DNA in the person that comes from those damaged eggs or sperm is likely going to have genetic abnormalities. Now, are they going to be significant? Are they going to cause any issues? Maybe not. Maybe not. How do we measure radiation exposure? So I'm going to be telling you about these, stupid pointer. I'm going to tell you about these different units, but these aren't going to be on a test, so don't stress out about these. Radiation can be measured as the number of decay events to which a person is exposed. So each decay event would be one nucleus reacting. And so a Curie, named after Madame Curie, Marie Curie, is equivalent to 3.7 times 10 to the 10th decay events per second. So that sounds like a lot, and it is. Another one is a Röntgen, which is 2.58 times 10 to the minus 4th coulombs of charge per kilogram of air.
Do we need to know these?
No.
Oh,
Didn't I say that?
Yes, you did.
Yeah, I did.
Oh,
They weren't
okay.
listening.
Well, I remember you said like, oh yeah, you're right.
Yeah.
some stuff, but
So I'm gonna-
numbers I thought.
No, I'm going to tell you about some different units for measuring radiation. This is just for your general exposure to knowledge, but you won't be tested on anything on this slide.
Isn't it kind of messed up naming this after Madame Curie? Because, you know, that's what killed her.
Well, but it honors her too, right? I mean, she gave her life for science. Now, did she know she was giving her life for science? Maybe not, but she did.
This is one of the instances where she should stay in the kitchen.
I'm going to leave that one alone. So that's a Röntgen. There's different ways to measure radiation exposure, and they're used in different situations. Human radiation exposure is often reported in REM, and REM stands for Röntgen Equivalent Man. So that's a weighted measure of the radiation exposure, which accounts for the ionizing power of different types of radiation. So if you're exposed to a given amount of alpha particles versus gamma rays, the same number of decay events is going to cause different effects, right? And it depends on whether you ate it or were just exposed to it outside. And so this accounts for different effects from different types of radiation.
What was the C in that?
C is coulombs. It's a measure of charge.
Coulomb, say it again.
Coulombs, Coulombs. That's a measure of charge. So this little pie graph gives us sort of a overall view of how are we exposed to radiation. On average, we're exposed to about 1/3 of a rem of radiation per year. That's the Röntgen Equivalent Man. Most of this comes from natural sources. I really want my pointer. What the heck? I really want my pointer. No, that's not going to work. It's just messed up. So radon, 55%. Cosmic terrestrial rays, internal radiation, 27%. Because you have carbon-14 in your body. And that is decaying, very slowly, but it is decaying. And so you are being exposed to radiation from the inside out. Do we need to be terrified about this? No. No, we don't. This has been going on all your life. You just didn't even know about it. You can't feel it. It's not really doing any harm. Medical sources are probably the biggest non-natural source of radiation, about 15%. And of course that is going to vary widely. If you're a person who never goes to the doctor, never breaks their arm, never gets x-rays on their teeth, it's going to be much, much less than that. And if you're someone who's having to get regular scans, it'll be higher. Other sources about 1%, consumer products about 2%. What are the effects of radiation exposure? The natural amount of radiation that we're exposed to is not going to produce measurable health effects in humans. our bodies have systems in place to deal with that level of radiation. The first measurable effects are going to be seen at around 20 rems. So this slide tells us in a year, we're usually exposed to about a third of a rem. So 20 rems is much higher. First measurable effect would be decreased white blood cell count. Probable outcome, you might have a possible increase in cancer risk at that level. If you get up to 100 to 400, there's radiation sickness, skin lesions, definite increase in cancer risk. And you get up around 500 and you're dead. You're going to die. How's that for cheerful? Does this one have? No, it doesn't. So this radon business, radon 55%. Radon is a daughter nuclide of the natural sequence of decomposition of uranium. And so there is radon naturally occurring in the ground. In some parts of the country, that level is much higher than in others. I attended high school and college in Iowa, and Iowa is a region where there's significant amounts of radon in the soil. And they also build basements. And so you have to have your basement tested to make sure that you don't have too much radon gas leaking in through the walls. Because breathing radon gets the radioactive stuff inside of you where it can cause more damage. And so that's a problem. But here in California, we don't have basements. We're good.